Welcome to the class, dear students. In last class, we have done the non-homogeneous differential equations, how to solve it. In today's lecture, I am going to discuss about the linear differential equations. So, what is the standard form of the linear differential equations? First, we write, and then we proceed to solve the problems. The standard form of the linear differential equation. What is that? It is dy by dx plus p of x times of y is equal to q of x. So this is what the standard form of the linear differential equation. So here there are some steps involved to solve this type of solutions. So steps to solve the linear differential equation. What we do now is, first step is we identify first of all what is p of x and what is q of x. Identify what is p of x, put it in the standard form and then see what is p of x and q of x. And then find integral of p of x dx. What it is, we have to find out. Next is find the integrating factor. Find integrating factor. Integrating factor. What is the integrating factor? It is given by e raised to integral of p of x dx. This is what the integrating factor. And now you write down the solution. So the solution is given by, the solution is y times of whatever the integrating factor you get, that is equal to integral of the right hand side whatever you have got, that is q of x times of integrating factor into dx plus the constant. So this is what the steps involved to find out the solution when the given equation is the linear differential equation. Let us now solve one problem. The equation is dy by dx plus 5y is equal to e raised to 2x. Okay. Now let us see this now. First, when you compare with the standard form, you can now identify what is p of x. P of x is 5. Okay. Let us equate this with the standard form. What is the standard form? Dy by dx plus p of x into y is equal to q of x. This is the standard form. So what you have got here, in the place of p of x into y, right? So in the place of p of x you have got 5. In the place of q of x you have got e raised to 2x. So we are writing that now. So that means it is q of x is equal to e raised to 2x. What is step 2 now? Find integral of p of x dx. So what is integral p of x dx? Integral 5 dx. What is integral 5 dx? Is 5x. Okay. Now we are going to find out what is the integrating factor. What is it? E raised to integral of p of x dx. So that is e raised to 5x. So this is the integrating factor. Now we can write down the general solution. What is the general solution for this? Is given by y times of integrating factor, it is e raised to 5x, is equal to integral of q of x is e raised to 2x into integrating factor is e raised to 5x dx. So what is integral of e raised to 2x into e raised to 5x? E raised to 7x dx. Therefore, what is the solution now? Y into e raised to 5x is given by e raised to 7x over 7 plus the constant. So this is the solution. This is the solution. I hope you are able to understand. So this is what the way to solve a linear differential equation. Now let us do one more problem on this. Solve the equation x dy by dx plus 3x plus 1 times of y is equal to e raised to minus 3x. Now, in before going to do this problem, I'll just give you some hints and then we will go to the problem. This one, just let me write down the problems here. The some note I will write. So there are some important points here you have to write here. What is e power ln of f of x? Always e power ln of f of x is f of x. Remember this one. Suppose if you have e power minus ln of f of x is there, then it is 1 over f of x. Suppose you have e power m times some constant m times of ln of f of x you have, suppose, then you will be writing this as e power ln of f of x the whole power m, and that gives you f of x the whole power m. So like this we will write. Okay. So these are the important things, that e power ln of any function means it is f of x. And e raised to minus ln of f of x is 1 over f of x. And e raised to some constant times of ln of f of x is f of x power m. Understood? So this is what the note you can understand. And now I am going to do the problem. So the second problem is x dy by dx plus 3x plus 1y is equal to e raised to minus 3x. This is what the question. So now what is first standard form? You have to always compare with the standard form. The standard form is dy by dx plus p of x into y is equal to q of x. So now is it in the proper standard form? No, right? Because dy by dx is always alone. So now divide the equation by what? By x, the whole equation. Okay. So when you divide the equation by x, this becomes dy by dx plus 3x plus 1 over x times of y is equal to e raised to minus 3x over x. So this is what we got after dividing by the equation. Now our job is to find out the solution for this. Let us see now what it is. So now this is what we have got here. So now what is p of x? Now it is in the proper form. What is p of x? It is 3x plus 1 over x. How can you write 3x plus 1 over x is 3x by x, which is x3 plus 1 over x. Okay. Next, what is q of x? Q of x is e raised to minus 3x over x. Okay. Now our job is find out integral of p of x dx. What is integral of p of x is what? 3 plus 1 over x dx. So now what is 3 times of integral dx is 3x, and integral 1 over x is ln x. So this is what your integral p dx. Now what is the integrating factor? It is e raised to integral of p of x dx, and that gives you e raised to integral of 3x plus ln x. Integral of p of x only is 3x plus ln x, right? So we write this as e power 3x plus ln of x. So how will you rewrite this? We know, do you know the formula that e power or x power m plus n can be written as x power m multiplied by x power n. We know this, right? By using the laws of exponents. So we can write this as e raised to 3x times of e raised to ln x. So what is this? E raised to 3x, e raised to ln x is x. So this is what the integrating factor. So therefore, what is the solution now? The general solution is now y times of the integrating factor is x e raised to 3x is equal to integral of q is e raised to minus 3x over x times of the integrating factor e raised to 3x into x dx. Now let us observe here what it is. This x and x gets cancelled, e raised to minus 3x and e raised to 3x also gets cancelled. You will be remain with integral dx, which is x plus the constant. Therefore, what is the general solution? X y e raised to 3x is equal to x plus c. So, this is the solution. This is the solution. So, with that is what the problem how to find out. Now, let us go to the third problem. Dy by dx minus y is equal to x. Now, it is in the standard form only, right? So, what is p of x here? Don't say it is 1, it is minus 1, okay? The coefficient here is what? You can observe very clearly that it is minus y. So, when you compare with the p of x y into y, p of x is minus 1. And what is q of x? Q of x is equal to x. Now, what is integral of p of x dx? It is integral of minus 1 times of dx, which is equal to minus x. Now, what is the integrating factor? Is e raised to integral of p of x dx. What is this? E raised to minus x. So, that is the integrating factor. Therefore, what is the general solution now? The general solution is given by, the general solution is y times of the integrating factor, which is e raised to minus x, is equal to integral of q is x, integrating factor is e raised to minus x dx. I hope it's clear. And now, how to solve this? That implies y times of e raised to minus x. How can we rewrite this? This by using the method of by parts. This is x into e raised to minus x. You know the Bernoulli's form. So, what is u here? U is x and dv is what? E raised to minus x. So, x derivative is 1, 1 derivative is 0. And e raised to minus x integral is minus e raised to minus x. Again, its integral is e raised to minus x. So, we have to multiply this and this and this and this. So, let us now have that one now. That is given by x minus x times of e raised to minus x and then minus e raised to minus x plus the constant. So, this is or else you can write the general solution as y e raised to minus x plus x e raised to minus x plus e raised to minus x is equal to c. Like that also you can write down the solution. So, that's what the problem by linear differential equation. So, let us now do one more problem. The fourth problem. Let us take this as cosine x dy by dx plus y sin x is equal to 0. Okay. Now, it is not in the standard form first, correct? So, what we do? We divide by cosine x. So, what we get? Dy by dx plus y times of what is sine by cosine is tan is equal to 0. Sine by cosine, sin x by cosine x is equal to tan x. So, this you know. So, next is we do dy by, now it's in the proper form. So, what is p of x here? It is tan x. What is q of x? Is equal to 0. So, what is integral of p of x? What is integral of tan x? Integral of tan x is ln of secant x. So, therefore, the solution, the integrating factor is what now? E raised to integral of p of x dx. But integral of p of x dx, we got it as ln of secant x. So, it is e raised to ln of secant x, which is equal to secant x. Therefore, the general solution is now, we have to write down the general solution. What is that? Y into integrating factor is secant x is equal to integral of q is what? 0 into integrating factor secant x dx. This whole thing becomes anyhow 0. So, the general solution is y secant x is equal to 0 plus c. So, this is what the solution. The integral plus the constant, right? So, this is what the solution you have to get. Let us now do next one more problem. We will do dy by dx plus y cot x is equal to cosine x. Now what is p of x here? It is cot x. And what is q of x? Cosine x. So what we can write here? Integral of p of x dx. That is integral of cot x. What is integral cot? Integral cot is minus ln of cosecant x. Minus ln of cosecant x. So therefore, what is the integrating factor? E raised to integral of p of x dx. So that is e raised to minus ln of cosecant x, which is equal to, I told you e raised to minus f of x is what? E raised to minus ln of f of x is what? It is 1 over f of x. This we have done. So therefore e raised to minus ln of cosecant x is 1 over cosecant x. Therefore what is the general solution now? The general solution is y times of integrating factor is 1 over cosecant x is equal to integral of cosine x, the q of x is cosine x, into 1 over cosecant x dx. Now all of you know what is 1 over cosecant x means actually, right? Which is sin x. So y sin x is equal to cosine integral of cosine x into sin x dx. Now how to solve this integral cosine x and sin x? You can take the substitution. T is equal to sin x, let us take. Then dt becomes cosine x dx. So that you can write this whole thing as now as integral of sin means t, cosine x dx means dt. So the value is t square over 2. So that means it is t means sin. So sin square x over 2 plus the constant. What is this? This is y sin x. So this is the general solution. I hope with this you could understand how to solve the problems which are of linear differential equations. One more problem I will do, and I will wind up this session. So the sixth problem is 1 minus x square times of dy by dx minus xy is equal to 1. Again, it is not in the standard form. So what we do? We divide by 1 minus x square. Now what we get? Dy by dx minus x over 1 minus x square y is equal to 1 over 1 minus x square. So what is p of x now? P of x is minus x over 1 minus x square, and q of x is 1 over 1 minus x square. So what is integral of p of x? Let us see. Integral of p of x dx is, take minus outside, integral x over 1 minus x square dx. So what we do? Whenever x is there and 1 minus x square is there, you can take the substitution as 1 minus x square. So x square derivative minus 2x dx is dt. So you can write x dx as minus dt by 2. Minus dt by 2. So this is what we get it as, minus of integral of x dx is minus dt by 2 over 1 minus x square is t. So this is nothing but take half outside, and 1 by t dt is ln t plus the constant. So it is half of ln of what is t? 1 minus x square plus the constant. So this is what your, okay, you need not write the constant because it is in p of x. Later at a time we can write down the constant. Okay, half ln of t, that is half ln of x square, 1 minus x square. So okay, so now therefore what is the integrating factor? The integrating factor is now e raised to integral of p dx, which is e raised to half ln of 1 minus x square. I have already told you in the note in the last slide that e raised to m times of ln x is given by x power m. So this is what I explained. So same the way it is what now 1 minus x square to the power of half. So this is what you are integrating factor. So therefore, what is the general solution? The general solution is y times of integrating factor, which is 1 minus x square power half, is equal to integral q is 1 over 1 minus x square times of 1 minus x square to the power of half dx. So next is we have to write this as 1 over 1 minus x square power half is nothing but y into 1 minus x square under root, you can write, or keep it like that also, no problem, half, and that is given by integral of 1 power half, and this is 1. So therefore it is what 1 minus x square power half dx. Okay. Now what is this? This is nothing but integral of 1 over square root of 1 minus x square dx. This is the formula. Integral of square root of a square minus x square is sine inverse of x by a. So it is sine inverse x plus c. And this is what y times of 1 minus x square under root. So that is equal to sine inverse x. So with this we have completed the linear differential equations. We have done it. So in this lecture I have explained you what is meant by the linear differential equation, what is the standard form, what are the steps involved to get the solution. All this we have done, and we have done nearly 6 problems we have completed. So I hope you have got the idea how to solve the linear differential equations.